Hello everyone, I'm Dr. Jahnavi Chakrabarti, Assistant Professor, Department of Mathematics, Bardhaman College of Engineering. Today in this video, I'm going to discuss how to find numerical solution of first order ordinary differential equation using modified Euler's method. First of all, we will consider the first order ordinary differential equation as dy by dx is equal to f of x comma y with the initial condition y at x naught equal to y naught. So here first of all we will find y at x1. To find y1, that is y at x1. x1 is equal to x naught plus h. By Euler's formula, we have y1 equal to y naught plus h into f of x naught comma y naught. So this one we can consider it as y1 0 equal to y naught plus h into f of x naught comma y naught. Now by modified Euler's formula, what we will have by modified Euler's formula, y1 n plus 1 equal to y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 n. Now let us put n equal to 0, 1, 2, 3 here. Put n equal to 0, 1, 2, 3 and so on. This is equation number 1 in equation 1. y1 1 is equal to y naught plus h by 2 f of x naught comma y naught plus f of x1 y1 naught. If we put n equal to 1, we will get y1 2 equal to y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 1. y1 3 equal to y naught plus h by 2 f of x naught y naught plus f of x1 y1 2 and so on. We will continue this process until we get two approximations are equal up to 4 decimals. Continue process until two successive approximations are equal up to 4 decimal places. So this is for y1. To find y2, that is y at x2. So here x2 is equal to x1 plus h. By Euler's formula, we have y2 naught will be equal to y1 plus h into f of x1 y1. Then by modified Euler's formula, we will get y2 n plus 1 y1 plus h by 2 f of x1 comma y1 plus f of x2 comma y2 n. So if we put n equal to 0, 1, 2, 3 and so on, we will get different values and we will continue this process until we get two successive approximations are equal. Similarly, to find y3, that is y at x3. So x3 will be equal to x2 plus h. By Euler's formula, we have y3 naught is equal to y2 plus h into f of x2 comma y2. By modified Euler's formula, we have y3 n plus 1 is equal to y2 plus h by 2 f of x2 comma y2 plus f of x3 comma y3 n. If we put different values of n 0, 1, 2 and so on, we will get y31, y32, y33 and so on. So let us see how we can represent this in general. Y k plus 1 n plus 1 is equal to yk plus h by 2 f of xk yk plus f of xk plus 1 yk plus 1 n, where k is equal to 0, 1, 2, 3 and so on. N is equal to 0, 1, 2, 3 and so on. So this is the general form of modified Euler's formula. Now let us solve problems using modified Euler's formula. Now look at this first problem where we need to find y value at x equal to 0.2 for the differential equation dy by dx is equal to y plus e power x using modified Euler's method. Given dy by dx is equal to y plus e power x with the initial condition y at 0 equal to 0. Here f of x comma y equal to y plus e power x, x naught is 0, y naught is 0, and we will choose h is equal to 0.2 to find y at 0.2. Therefore, x1 is equal to x naught plus h. x naught is 0 plus h is 0.2. Which is 0.2. Now let us use Euler's formula first. By Euler's formula, we have y1 0 equal to y naught plus h into f of x naught comma y naught. So here y naught is 0 plus h is 0.2, f of 0 comma 0. f of xy is y plus e power x. So 0.2 y plus e power x. So we get y1 0 equal to 0.2. Now by modified Euler's formula, we have y1 n plus 1 y naught plus h by 2 f of x naught comma y naught plus f of x1 y1 n, which is equation number 1. Put n equal to 0, 1, 2, 3 and so on in equation 1. y1 1 is equal to y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 0. y naught is 0 plus h is 0.2 by 2. f of x naught is 0, y naught is 0 plus f of x1 is 0.2, y1 0 is 0.2. So we have this is 0.1 and f of 0 comma 0, this will be 0 plus e power 0 plus 0.2 plus e power 0. So if you calculate this, you will get 0.2421. Now we will put n equal to 1. We will get y1 2 equal to y naught plus h by 2 f of x naught comma y naught f of x1 comma y1 1. y naught is 0 plus 0.2 by 2 into f of x naught is 0, y naught is 0 plus f of x1 is 0.2 and y1 1 is 0.2421. So we have this is 0.1 into 0 plus e power 0 plus 0.2421 plus e power 0.2. So if you compute this, we will get 0.2464. Now next we have to find y13. So y13 is given by y naught plus h by 2 f of x naught comma y naught plus f of x1 y1 2. y naught is 0 plus 0.2 by 2 f of 0 comma 0 plus f of x1 is 0.2 0.2464. So we have 0.1 into this is 0 plus e power 0 plus 0.2464 plus e power 0.2. If you compute this value, you will get 0.2468. Next we will find y14. y14 is equal to y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 3. y naught is 0 plus h is 0.2 by 2 f of 0 comma 0 plus f of x1 is 0.2 and y1 3 is 0.2468. Thus we have 0.1 into 0 plus e power 0 plus 0.2468 plus e power 0.2. Now if we compute this value, we will get 0.2468. So look at these values. These and these are equal. Since y13 is approximately equal to y14, we stop the process. Therefore, y at 0.2 is equal to 0.2468. Now look at the second problem where we need to use modified Euler method to find the approximate value of y at x equal to 0.3. An equation is given by dy by dx is equal to x minus y with the initial condition y at x equal to 0 is 1. Given dy by dx is equal to x minus y with the initial condition y at 0 equal to 1. Here f of x comma y is equal to x minus y. X naught is 0, y naught is 1, and we will choose h is equal to 0.1. Now we need to find y at x1. To find y at x1 or y1, here x1 is equal to x naught plus h. X naught is 0, h is 0.1, so x1 is 0.1. By Euler's formula, we have y1 0, which is equal to y naught plus h into f of x naught comma y naught. Y naught is 1 here, 1 plus 0.1 into f of x naught is 0, y naught is 1. So 1 plus 0.1, 0 minus 1, because f of xy is x minus y, so here 0 minus 1. So we get 1 minus 0.1, which is equal to 0.9. Therefore y1 0 is 0.9. Next we will find y1 1. So for that we will use modified Euler method. By modified Euler method, we have y1 n plus 1 equal to y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 n. Let us give this as equation number 1. Now we will put n equal to 0, 1, 2, 3 and so on in equation number 1. y1 1, which is equal to y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 naught. Now let us substitute the values. Y naught is 1 plus 0.1 by 2, f of 0 comma 1 plus f of x1 is 0.1 and y1 naught is 0.9. We get 1 plus 0.1 by 2 and this one is 0 minus 1 plus this one will be 0.1 minus 0.9. If we compute this value, we will get 0.91. Next we will find y1 2. y1 2 will be given by y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 1. We have y naught is 1 plus 0.1 by 2 f of 0 comma 1 plus f of x1 is 0.1, y1 1 is 0.91. We have 1 plus 0.1 by 2, 0 minus 1 plus this one will be 0.1 minus 0.91. If we compute this value, we will get 0.9095. So these two are still not equal, so we will find another one, y1 3. y1 3 is given by y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1. y naught is 1 plus 0.1 by 2 f of x naught is 0, y naught is 1 plus f of x1 is 0.1 and y1 2 is 0.9095. We get 0.909525. Up to 4 decimal places, this and this are same. Since y12 approximately equal to y13, we get y1 or y at 0.1 is equal to 0.9095. Now we will find y at x2. To find y at x2 or y2, here x2 will be equal to x1 plus h. x1 is 0.1, h is 0.1. So we have 0.2. By Euler's formula, we have y2 naught is equal to y1 plus h into f of x1 comma y1. y1 is 0.9095 plus h is 0.1, f of x1 is 0.1, y1 is 0.9095. So we get 0.9095 plus 0.1. This is 0.1 minus 0.9095. If we compute this, we will get 0.82855. Now we will find y21, y22 and so on using modified Euler's method. y2 n plus 1 equal to y1 plus h by 2 f of x1 comma y1 plus f of x2 comma y2 n. Let us give this as equation number 2. Now we will put n equal to 0, 1, 2, 3 and so on to get y21, y22 and so on. We have y2 1 is equal to y1 plus h by 2, f of x1 comma y1 plus f of x2 comma y2 not. y1 is 0.9095 plus h is 0.1 by 2. f of x1 is 0.1, y1 is 0.9095 plus f of x2 is 0.2 and y2 not is 0.82855. So we have 0.9095 plus 0.1 by 2, f of xy, x minus y, 0.1 minus 0.9095 plus 0.2 minus 0.82855. If we compute this value, we will get 0.8376. Now next we will find y22. y22 is given by y1 plus h by 2, f of x1 comma y1 plus f of x2 comma y21. y1 is 0.9095 plus h is 0.1 by 2. f of x1 is 0.1, y1 is 0.9095 plus f of x2 is 0.2 and y21 is 0.8376. If we compute this value, we will get 0.837145. Now we will find the next one, that is y23. So we will continue this process until we get the same approximations. So now y23 will be given by y1 plus h by 2, f of x1 comma y1 plus f of x2 comma y22. y1 is 0.9095 plus h is 0.1 by 2, f of x1 is 0.1, y1 is 0.9095 plus f of x2 is 0.2 and y22 is 0.837145. We have 0.9095 plus 0.1 by 2, 0.1 minus 0.9095 plus 0.2 minus 0.837145. If we compute this value, we will get 0.83716. So y22 and y23 up to 4 decimal places, these two are same. Since y22 is approximately equal to y23. So we have y2 or y at 0.2 is equal to 0.8371. Now next one we will find y3 or y at x3, that is equal to 0.3. To find y3 or y at x3. Here x3 is equal to x2 plus h. x2 is 0.2 plus 0.1, that is 0.3. By Euler's formula, we have y30 is equal to y2 plus h into f of x2 comma y. y2 we have as 0.8371 plus h is 0.1, f of x2 is 0.2 and y2 is 0.8371. We get 0.8371 plus 0.1 into 0.2 minus 0.8371. If we compute this value, we will get 0.7734. Next, using modified Euler method, we will find y31, y32 and so on. By modified Euler's method, we have y3 n plus 1 is equal to y2 plus h by 2 f of x2 comma y2 plus f of x3 comma y3 n. Let us give this as equation number 3. Now put n equal to 0, 1, 2, 3 and so on in 3. We get y3. If we put n equal to 0, we get y3 1 equal to y2 plus h by 2 f of x2 comma y2 plus f of x3 comma y3 0. y2 is 0.8371 plus h is 0.1 by 2. f of x2 is 0.2, y2 is 0.8371 plus f of x3 is 0.3 and y3 naught is 0.7734. We have 0.8371 plus 0.1 0.1 by 2, and this is 0.2 minus 0.8371 plus 0.3 minus 0.7734. If we calculate this, we will get 0.7816. Next, we will find y32. So y32 is given by y2 plus h by 2, f of x2 y2 plus f of x3 y3 1. We get y2 is 0.8371 plus 0.1 by 2 into f of 0.2 0.8371 plus f of 0.3 comma y31 is 0.7816. If we compute this value, we will get 0.7811. Next, let us find y33. y33 is given by y2 plus h by 2, f of x2 comma y2 plus f of x3 comma y32. y2 is 0.8371 plus 0.1 by 2, f of x2 is 0.2, y2 is 0.8371 plus f of 0.3 and y32 is 0.7811. If we compute this value in calculator, we will get 0.7812. Now let us find y34, because we will check up to 4 decimal places whether it is equal or not. y34 is equal to y2 plus h by 2, f of x2 comma y2 plus f of x3 comma y33. y2 is 0.8371 plus h by 2 0.1 by 2, f of x2 is 0.2 0.8371 plus f of 0.3 and y33 is 0.7812. So we will see, if we compute this value, we get 0.7812. Up to 4 decimal places, y33 and y34 are same, since y33 approximately equal to y34. So y3 or y at 0.3 is equal to 0.7812, which is the required answer. So this is how we use modified Euler's method to find the numerical solution of first order ordinary differential equation. Thank you.